Hi, everyone, and welcome back. This is Alexander Lim, and we are on another episode of AuthorStory. Our featured book is Out There, A Scientific Guide to Alien Life, Antimatter, and Human Space Travel for the Cosmically Curious, which you can check out right now by clicking the Amazon link in the video description below. Its author, Dr. Michael Wall, is Space.com's senior writer whose wide array of scientific contacts has helped give him insights into what is presently going on in space exploration and other scientific endeavors. So, Mike, welcome to Author Story. Thank you very much for being our guest.
Thank you for actually having me on. Really
You're,
appreciate it.
you're welcome. You're welcome. So, Mike, what made you decide to write Out There? Was this something that you decided like an aha moment that you had, or was it something like you wanted to create over time?
Yeah, it's just one of those things. I mean, yeah, like I always wanted to actually write a book, but I never really knew what it was going to be about. And
Mhm.
then just having just like working at space.com since 2010,
Right, right.
there's been a lot of really interesting stuff happening in space exploration over this time period. It's like a really exciting, action-packed kind of time
Uh-huh, uh-huh.
in like a variety of ways. And like one of the things that's happening really fast is people are taking the kind of search for alien life more seriously now, and we're
Right,
actually
right.
learning a lot more about our universe.
Uh-huh.
And all these thoughts about, are we alone? Could we be alone? If there is alien life out there, what might it look like? Where might we find it? We're
Mhm.
actually starting to get to the point where we can maybe answer some of these questions, and not just by kind of waving our arms around, but by actually gathering data and doing real exploration. So it seemed like that was happening, and then at the same time, private spaceflight is sort of really taking off.
Right.
If you'll pardon the like bad pun, but yeah, I mean, you've got all these private. I mean, you've got billionaires getting involved. Elon Musk obviously involved. Richard
Right.
Branson.
Right.
Um, and yeah, I mean, Bezos also has a spaceflight company, richest man in the world. And so there's all this momentum building for us to try to get off of Earth in a meaningful way for the first time ever. Go start like a colony on Mars, which is that's what Elon Musk wants to do. That's what he wants to spend all of his fortune doing.
Right.
So yeah, both of these things are happening at the same time, and it just seemed like a good time to write a book about them and try to get people interested in what's going on, because there is a lot going on.
Right. Okay. Now, from what I hear from your voice, it seems that there's a certain amount of wonder in what's presently going on. As a kid, I'm just curious, what was it that made you wonder about the universe? Is there ever a time when you did something like, lie on the roof of your house, look up at the sky, and wonder about what the heck was up there?
Yeah. I mean, like that's probably something that all of us can identify with. I mean, from my perspective, it was probably camping. I mean,
Uh
it's
huh.
like we went camping, not tons, but I mean a fair bit. With like my dad really liked doing it, and so did I. And so being out under like a really dark sky, getting away from like the bright city lights where you can really see a lot of stars. And yeah, I mean, yeah, like that probably played some part in it, where you're out in this just like total darkness, and you can really
Right.
see the stars. You can see thousands of them. And I mean, yeah, I mean, most of us have had moments where we look up at a scene like that, and it puts it into perspective. There are all these stars up there, and they're all fairly similar to our sun, probably. Well, although we can talk about that. Actually, most of the stars in
Uh
our
huh. Uh
galaxy are like red dwarfs, which are a lot smaller than our sun. But
huh.
yeah, they're all solar systems up there. And so how could we be the only thing that's here, the only, yeah, like the only creature? It just doesn't make any sense.
Yeah, true, true. Okay, so Mike, I'd just like to talk a little bit about recent common events, recent current events. Like the one I want to talk about is like the picture of the black hole Povegui in Galaxy
hmm
M87. And I've
hmm
seen the images, but what exactly are we seeing? Is it the black hole itself?
Yeah, well, you like can't actually see into a black hole. I mean, yeah, like not unless you're unfortunate enough to get sucked into it.
Right, right, right.
Because obviously not even light can actually get like out of a black hole. So there'd be nothing to actually photograph you. Like yeah, like there'd be no photons. But like what you're seeing is it's sort of silhouette. Like what you're seeing is like
Mm,
it's actual boundaries which
mm,
are defined by the event horizon,
right,
which
right,
is that sort of line that yeah, I mean beyond which nothing can actually escape its pull.
right, right.
So that kind of fuzzy black kind of sphere right in the middle, that's where the black hole is. What you're
Ah,
seeing with that darkness is that's where it is. And you can't actually see it, but you're seeing its like silhouette basically. And
I
it's
see.
really cool. It's 55 million light years away. So
Mhm.
there are some people complaining on Twitter that it was fuzzy or something. It wasn't a good picture. It's like, and it's like you got to lower the bar for your expectations a little bit. It's a fantastic observation to see something so far away.
Yeah, I mean that's quite a distance, and I mean for
Yeah.
something that has not been exactly photographed before. I mean this is the first
Yeah.
picture you've got, right?
Yeah, it's pretty amazing. I mean, people were pretty sure black holes exist. I mean, but this is the first time we photographed one, and actually having a picture of it like it actually tells us a lot. You know, based on the shape of the event horizon, the size of the event horizon, you can actually test Einstein's theories. And it turns out he was he was pretty right. Einstein's theory of general relativity, which basically lays out gravity for us. I
Right.
mean, you can make some tests of that based on this picture, and I mean, surprise, surprise, Einstein was actually right about that again. So, I mean,
Right.
we don't need to revise his whole gravity theory, which is pretty amazing that he could actually picture this stuff 100 years ago and
Yeah.
and kind of write out that math. It's just he was a staggering genius, obviously.
Yeah. I mean back then there were not like the computers that we had, the imaging capability that we had, and he,
No,
he predicted it. Yeah.
yeah, yeah.
All right. So l- let's get on with one of the topics the book covers. I mean extraterrestrial life. Now we're all used to life being as we see around us, but other planets don't have to look like Earth, right? I mean, like just thinking historically, like Precambrian, Cambrian flora and fauna, they would look pretty strange to us if we saw it right now.
Yeah.
What in your opinion is the most likely form of life that we would find out in the universe?
Well, I mean, I would guess most of the life we will run across whenever we kind of like do get up and running in the search is probably microbial, just because that's the first step that we took, and we were in the kind of microbes only stage here on Earth for about 3 billion years.
Right,
Um, so it seems like it's not that hard to basically for microbes to arise based on our experience here on Earth. Like we had life here probably about 4 billion years ago, maybe even a little longer ago than that. So pretty much as soon as our planet had cooled off enough after its formation to be able to support life
right,
popped up here. But then it stayed single celled only for another 3 billion years,
right,
and then so that sort of suggests that there's some big hurdle to getting past microbial life. And I mean, if our planet's any guide, and we don't know that it is, but it's the only thing that we really have to actually go on to
right,
speculate about this stuff.
right.
It seems like, yeah, I mean, it seems like microbial life should be pretty common, but
Mhm.
like it'll be a little more rare to find animals and plants and other things that we would like kind of call complex life. So yeah, that'll be my sort of guess is that the first thing we find is going to be a microbe somewhere.
All right, all right. So I guess like meeting like intelligent races like in big science fiction stories like Star Trek, Star Wars, that sort of thing. That's still quite a bit of a ways away.
Well, yeah, I mean, probably, but we don't know, right? It's
Yeah,
all we haven't heard anything yet, so it seems like intelligent life is not just like everywhere, but space is really big, and there's a huge time span that we're trying to deal with too. I mean, we've been around as like an intelligent technological civilization for about 100 years, maybe. That's about how long we've been pumping radio waves out into the galaxy.
right,
And this is in like a universe that's almost 14 billion years old.
right, right,
And so we would have to kind of overlap pretty precisely in time with any other civilization that we're trying to contact. And what are the odds that we would have been able to actually do that in the past 100 years? And that's even optimistic because we've only been kind of searching for about 50 years.
right.
So what are the odds that we find something in the past 50 years of the 14 billion year history of the universe? And then you kind of add into that, space is really, really big. So
Yeah,
it takes a long time for these light signals to cross from star system to star system. I mean, it's possible that there are a lot of intelligent civilizations kind of like that, they're kind of scattered across the cosmos, but they're so far away from us that we haven't gotten their like signals yet, or like maybe these civilizations have actually risen and died long before we arose, or you can get into the ET psychology stuff, and it's like, well, it's like, what if they're out there but they're not trying to communicate? What if they're kind of worried that they don't want to pop their sort of heads up, and because they're worried about them getting chopped off by some evil civilization like the Borg from Star Trek or something. So there are all these possible explanations for why we haven't heard anything yet. And yeah, I mean, it is a mystery, and nobody has any answers. It's probably like a combination of a bunch of things, but nobody knows.
Right. And I guess it'll take time before we figure out if there are any answers in the first
Yeah.
place.
Yeah.
Okay. So let me just throw a couple of things in here. Like, I know with life over here, it's essentially based in carbon and oxygen. Those are the main building blocks of life here on Earth. Is there a possibility there are life forms that use other chemicals, like, say, for example, fluorine, a fluorocarbon type life form?
Yeah. I mean, we think, I mean, it's probable that the kind of most of the life we kind of run across will probably be sort of like us. I mean, carbon based, like, not to say that it would use DNA and our same proteins and all that stuff. That would be a huge coincidence. I mean, unless we're all related, which we could talk about too, which is a possibility. But I mean, carbon is really common throughout the entire universe, and so are complex carbon molecules. They just tend to arise of their own accord in deep space. I mean, we find amino acids on comets and on asteroids that are just there.
Right.
So and carbon works really well with actually liquid water, which all life here on Earth depends on to it's a solvent. All of our nutrients get dissolved in it, and that's how we get all of the stuff that our cells need to survive. Is it gets sloshed around in the water that we depend on.
Mm-hmm.
So it seems like carbon water life is really probably likely, but that's not to say that that's the only life that there could be. I mean, people who have seen Star Trek probably know about the Horta. It's like this like silicon-based life form, and that's a possibility. I mean, silicon's very similar to carbon. It does a lot of the same things chemically, so it's possible that there could be a silicon-based life form. It would have to be in a really different environment. It would only work where it's pretty cold, and it probably wouldn't use water as a solvent. Maybe some really cold liquid. So it would be pretty exotic, but that's a possibility. So yeah, I mean, it's like, we don't know. I mean, carbon water life is probably the most common kind of life out there, but it's definitely not the only kind that we could run across.
Right. And I'd like to go back a little to something you mentioned. I mean, something like we're all related, even if we don't use DNA or that sort of thing. What do you mean by that?
Well, there are some people. I mean, like I was talking earlier about how life on Earth got started really, really quickly, right? Like, I mean, pretty much as soon as it possibly could here on Earth. So there are some scientists who take that data point and they're like, that's kind of suspicious. And it was complicated life here fairly quickly. I mean, microbes were like doing all sorts of biochemically complex things fairly quickly. Mm-hmm. And there are some scientists who think that that's not super likely, that would just happen. And so there's this idea, panspermia, which is basically that life is actually widespread throughout the solar system and probably galaxy, mm-hmm. and that it just sort of it kind of hops from place to place on comets or asteroids, or maybe even driven on little bits of dust driven by sunlight, starlight. And I mean, there's no evidence for this idea. I mean, nobody's found alien life and determined that it's actually related to us or anything. Obviously, we would have heard about it.
Right,
but it's just sort of like suggestive to a lot of people that since things happened here so fast, it's possible that it could have just kind of fallen from the skies rather than crawled out of the kind of primordial soup like we're all used to hearing about. So I mean, I don't know what the answer is, and nobody does, but that's it's one idea that people toss around.
Right. Okay. So let me get on to another topic. Human space travel. I mean, as you mentioned, I mean, this is big right now. I mean, let's face it, it's 2019, but we're not exactly the state of Arthur C. Clarke's imagination. 2001 would be traveling to the moon would be a routine thing. What is the present state of human space travel?
I would say it's not where we want it to be, but it's on an upward trend. I mean, obviously, it's been since 2011 since the United States has been able to put an astronaut into orbit. That's when the space shuttle's retired, and that's changing. Actually, SpaceX is probably going to launch American astronauts to the space station later this this year, possibly this summer. But all these dreams about, going to the moon, going back to the moon, going to Mars, I mean, people thought that that would have happened. I mean, if you ask people right after the Apollo program ended in the 70s, where will we be in 50 years? They would have probably said pretty confidently, we will have put boots on Mars and so on and so forth. And it's disappointing that that hasn't happened yet. And there are a lot of reasons for that. I mean, a lot of them are, politics and how much money it would have taken. I mean, it would have had to give NASA a lot more money than they actually did and put them on a different direction, and like not have that direction kind of jerked back and forth by various presidents like over the years. So all these things have kind of conspired to keep us confined to low Earth orbit. And but it's on an upward trend because of all this money in the private sector that is doing big things. I mean, like we were talking about Elon Musk and SpaceX. He founded SpaceX in 2002, and that was the main goal, was to get people to Mars and to help humanity become a multi-planet civilization. And he said multiple times over the years that that's the whole point. That's why he got rich, and that's what he wants to do with his money, is to get us like onto Mars in a sustainable and a permanent way. And so I don't doubt his sincerity at all. I don't think it's a stunt. I think he's dead serious about it. And I mean, they've done really good things at SpaceX. They're advancing toward that goal. So I think that I mean, you see similar progress with Blue Origin, which is Bezos's spaceflight company. I mean, and he's the richest man in the world, and he's got a keen interest in space and getting. I mean, he has said he wants millions of people living and working in space. That's the ultimate goal of his spaceflight company. Right. So there's a lot of money going into this, and they're really serious people. And so, that's part like we're sort of at an inflection point, a possible inflection point, I think, where lots of exciting things could be happening over the next, 5 or 10 years or so. We'll just have to wait and see. People who have had these big space dreams have been like disappointed in the past, obviously, because it hasn't happened yet. But now there's serious money involved, and I'm fairly optimistic that exciting things are going to happen in the next, 15, 20 years. I don't know about 5 to 10, but soon.
Right. Okay. So, staying on the topic of space travel, I mean, with regards to propulsion, I mean, actually getting humans somewhere, what sort of propulsion would actually be used that you foresee would be used in the next 10 or 20 years? Is this going to be sort of like the rocket thing that's always been, or something else?
On that short time span, I don't think we're going to have any big propulsion breakthroughs in the next 10 to 20 years, and that's what we would really need to actually go to interstellar space, or to take people to interstellar space. I don't think in the next 10 to 20 years we're going to figure out a way to get to Mars in 2 weeks or anything like that. We're going to need rockets, and it's going to take months. Right. But over the longer haul, there are possibilities for us to get much faster, and maybe even get up to significant fractions of the speed of light. And some of the things that people talk about as being the most sort of likely candidates for that is, if we could figure out nuclear fusion rockets, and that's a shorter term horizon goal. I mean, it's not easy and it's not close, but it's closer than something like a antimatter engine or something sci-fi like that. It's probably hundreds of years away if we get it at all. So that's a possibility. And there's another thing. I mean, laser sails are something that we're trying to do now, and that's maybe not for people, at least not in the near term. But that's something that could accelerate like a tiny probe. Basically, it's like a little tiny robotic probe that once it gets up into space, it actually unfurls this big silver, really reflective, really light sail. Right. And it can be pushed along by sort of sunlight pressure, radiation from the sun, or you could blast it with an Earth-based laser. And if you hold that laser on it for long enough, you can accelerate it to huge speeds, like 20% speed of light. And there's a project that's trying to kind of work out how to do that right now. Breakthrough Starshot is what it's called. It's like $100 million project where they want to launch a bunch of these little laser sailing probes to the nearest star system, Alpha Centauri. Right. And they actually want to do that in the next 25 years or so. So, I mean, who knows if they'll do it, but there are people who are putting serious money into that and trying to do it. So we're going to see over the relative kind of short term if that's feasible in the relative short term. So things are happening.
Okay, all right, cool. So that's a window into future propulsions methods then.
Yeah, yeah.
Okay, so next thing I want to talk about is antimatter. I mean, you mentioned Star Trek. I mean, Star Trek starship drives are powered by antimatter. I mean,
Hmm.
this is stuff science fiction, but first off, for the benefit of everyone listening, what exactly is antimatter?
Yeah, yeah, like it is sci-fi, but it's actually real. I mean, antimatter does exist. It's like the kind of bizarro version of the normal stuff that we're used to. So there are things called like a positron, which is like the like anti-electron, and it's weird. Like it was created like along with regular matter back during the Big Bang.
Right.
Um, but it's just there's not much of it left in the universe. Nobody really knows why there's way more matter than actual antimatter. It's one of the
Right.
big mysteries of astronomy. But and so when like matter meets up with its antimatter counterpart, it like annihilates. Basically, both of them get immediately vaporized and they turn into pure energy. And it's a perfect conversion of mass to actual energy. It's like 100% conversion,
Wow.
which is why everybody gets so excited about it from propulsion. Because if you can harness that conversion, it's 100%. It's 100% efficient.
Right.
So it would be extremely powerful for an energy source. But there's a couple problems. First, there's not very much antimatter out there, and it's really hard to actually make in the lab. I mean, you can make it with these big particle accelerators that we have, but it's really really expensive, and you can only make tiny amounts. So in the near term, we're never going to do that on any kind of big level. And then there's the containment thing.
Right.
Since antimatter will explode basically anytime it hits regular matter,
Yeah.
it's really hard to like deal with. It's really hard to transport it or to contain it. You basically have to trap it in like a magnetic field so it doesn't touch anything. I mean, it couldn't touch like the like wall of a canister or a jar. It would
Right.
annihilate everything.
Yeah.
So
Right.
so how you would get enough of it first of all, and then how you would kind of like contain it so it doesn't blow everything up around you. It's a tricky challenge, and that's like those aren't challenges that we're going to solve in the short term. I mean, maybe a few hundred years down the road, but yeah, it's a pretty tall order.
Yeah. I just like to give a little explanation to our listeners because antimatter is something like the opposite, as you mentioned, of what matter is. Like an electron is negatively charged, a positron, the antimatter equivalent would be
Hmm.
positively charged,
Right,
and
right.
so on and so forth.
Yeah, yeah,
Okay.
yeah.
So, do we have any idea about why there's, you know, uh, the asymmetry between matter and antimatter that's produced when the universe is formed?
No, it's sort of one of those. It's like one of the big mysteries that scientists are trying to actually work out. Nobody really knows why. Like because theoretically there should have been like they should have been produced in like equal amounts, and
Yes, yes.
it's pretty unclear why kind of matter has come to dominate. Yeah, that's something scientists are trying to figure out.
Right. Okay. So I'd like to go into another topic. I'm not sure if you're into this, but I mean like multiple universes. This sort of thing has got to blow a lot of minds. Can multiple universes actually exist?
Yeah, and people, I mean, most theoretical physicists who work on this stuff think that they do. It's basically, yeah, I mean, people think, yeah, based on how, like, yeah, how our universe started, and all the physics involved in that. I mean, scientists think that like, yeah, like our universe was basically only one of a bunch of little bubbles that kind of pinched off during the Big Bang, and
Right.
all these bubbles grew into their own unique universes.
Right.
And yeah, I mean, I think that's pretty much most scientists think that it's true.
Mhm.
And how you could ever test that or access that, or I mean, I don't know that that's ever going to be possible, but yeah, it's very likely, I think, that there are the universes out there, and I mean, they could have different laws of physics. They could be so bizarre. They could have different numbers of you know of like dimensions.
Right.
It's mind-boggling to kind of think about it because it doesn't make any sense to us. But that's kind of what the math tells them.
Mhm. So there's a possibility that we could have a world like, say, what's in J.R.R. Tolkien's Lord of the Rings trilogy. I mean, we could have a world like that, heavy in
Yeah,
magic rather than science.
yeah, it's possible. And what's really interesting is that I mean, yeah, I mean, our own universe is probably infinite too. That's sort of, I mean, nobody, I mean, people aren't sure about that, but that's what the theory suggests, and that's what observation suggests, that it seems to be infinite. I mean, we're trying to work out if that's true or if it's just really, really, really big. But yeah, if our own universe is actually infinite, then yeah, you get into all sorts of crazy kind of mind-bending things that are reality. Because if you have infinity, then pretty much anything that is physically possible will actually manifest somewhere.
Right.
So yeah, I mean, in our own universe, probably magic doesn't work in our own universe because of the laws of physics and stuff.
Right.
But like any kind of creature you can like actually think of that is physically possible will occur somewhere in an infinite universe. And that also means that there are alternate versions of you and me and pretty much everybody that's ever existed, like
Okay.
somewhere
Okay.
really, really, really far away,
Right.
but somewhere. So yeah, all this stuff, like once you start thinking about it, like the implications of an infinite universe are pretty crazy, really.
Right.
And then yeah, and then if you have multiple universes, then that adds on to the craziness because you get more possibilities, and yeah, there's more of everything, and it's just yeah, it just makes your head spin.
Yeah, I mean, like concept of multiple infinite universes. I mean, that's really a mind bender right there.
It's crazy, and that makes you really yeah, that's the sort of thing where it's like how can we be like the only inhabited planet or the only inhabited world? It just doesn't seem feasible.
Right. Right. Okay.
Yeah.
All right. So I'd like to go to a little to another topic that well, you kind of mentioned that the universe seems to have be infinite in size. This, I guess, is related to how our universe will end. I mean, I think all universes and all things end eventually. Uh,
Hmm.
given what we know, what do you think is the ultimate end demise of the universe?
Yeah, well, there are two kind of possibilities, right? There's some people who think it'll end in fire, and some think it'll end in ice. And it
Hmm.
seems like ice is going to win out. It seems like there's not enough mass in the universe to kind of bring everything back together again by gravity.
Hmm.
So like we're in an expanding universe. It's been expanding since it began with the Big Bang, and
Right.
that like that acceleration is actually, or that expansion is actually accelerating,
Right.
which is weird. And like we think something weird called dark energy that we don't understand is driving that acceleration.
Right.
But since we're still expanding, people have done the math based on what we can see in telescopes, how much mass there seems to be in the universe. It seems like it's going to just keep expanding forever. And it doesn't seem like there's enough mass everywhere to kind of bring everything back together in like a big crunch, which is what would happen if there was more mass. You know, all the combined gravitational pull of everything in the universe would kind of counteract that expansion and draw everything back together into a, and then everything will get sucked into one single point, and it would be really crazy and really, really destructive, and that's how it would all end. But that doesn't seem to be the case. It seems like there's not enough stuff in the universe, and we're just going to keep expanding forever. And eventually, stars are going to be really far apart, and eventually, galaxies are going to be really far apart. And in the very, very, very far future, like when you look up in the sky, there you won't see any other stars. It'll just be darkness because everything will be so far apart, and then everything will freeze to death, and everything will die, and that's going to be the end.
Okay.
That's probably what's going to happen.
And that might also happen on the quantum level, right? I mean, you could have atoms fly apart,
Yeah,
neutrons,
yeah,
protons, they'll actually become quarks and all that stuff, whatever that may
yeah.
be.
That's like that's the ultimate fate of the universe is eventually even yeah, I mean even like atoms will like degrade, will fall apart into their constituent particles. And yeah, so soon like at the very end of the universe, you're talking like trillions of years in the future, there will not even be any atoms. There will just be these little subatomic particles zooming around, and that's pretty much all there will be. There will not even be stars or anything because everything will have fallen apart into quarks and other tiny subatomic particles, and that's the ultimate fate of the universe. And those will just be screaming through the darkness, and that's it.
Right, right. Okay. So Mike, there are a lot of books out there in science, exploration, discovery. How do you think your book will stand up compared to such classics as Dr. Sagan's Cosmos and Professor Hawking's A Brief History of Time?
Oh yeah, well I would not put like my book on that level. They were geniuses, and I'm just trying to make a little foray into telling people about how exciting this time is and what's going on.
Right.
Um, yeah, I would not put my book on the same level. That would be very hubristic of me. I just hope it's a popular science book, and there are a lot of jokes in there. Most of them are bad, but
Right.
it's trying to get across to people just the kind of sense that something big is actually happening,
Right.
and that they just to make people aware of that, because we can get so like caught up in our day-to-day lives, and there are so many distractions. And yeah, I just want people to kind of take the time to kind of look up, and I wanted to tell them the story of these two kind of twin stories that are happening right now with the kind of search for alien life and our quest to like get off of Earth. And hopefully I'll open a few minds and keep people entertained along the way. And that's, yeah, hopefully that'll happen. That's the intent of the book.
Okay, cool. Okay, so Mike, let's say you come across someone who's, kind of wondering what's out there beyond the Earth, beyond the solar system, be it, extraterrestrial life or some other universal wonder. And you had only enough time to tell that person one thing about essentially life, the universe, and everything. What would be that one thing you'd tell them?
I would tell them that we don't know, but we're seems like we're poised to find out. So if they're patient, if they can wait about 10 or 15 years, then we'll probably have some pretty big answers. And I actually think that's true. I don't think that's kind of overly optimistic. There are multiple worlds in our own solar system that are capable of supporting life. I mean, Mars was an ocean world long ago, and yeah, Venus was too. And if those worlds ever had life, I mean, our own experience here on Earth tells us it's really hard to completely stamp out. So it's easy to kind of imagine some subterranean like kind of aquifer on Mars, which it has lots of. If I
Mhm.
mean, there being pockets of sort of subsurface life on Mars, which or I mean, people talk about Venus. I mean, Venus dried out, and now it's a hellscape on the surface. But if you go up into the clouds, it's pretty balmy. It's pretty nice up there. So it's possible that, I mean, if life ever evolved on Venus, it's not on the surface anymore, but there actually could be microbes up in the sky about 20 miles up. And then there are these moons of the outer solar system that have huge oceans under their ice shells. And I mean, oceans, I mean, liquid water, salty liquid water, and an energy source. I mean, that's what you need for life. So it's possible that there are microbes or something else swimming in these oceans of these outer moons even today. So I
Right.
mean, and we're actually trying to explore some of these worlds now in a serious way. So yeah, I would tell those folks, this is really happening. It's not just a sci-fi dream anymore to think about an encounter with another like kind of life. I mean, I think it's possible, and it could actually happen in our lifetimes. I would be disappointed if it doesn't happen in my lifetime, but yeah, like we'll see.
All right, cool. We'll see. Well, definitely. I mean, a lot's going to happen in the next 15, 20 years, you say.
Yeah, yeah, and yeah, I mean, NASA's like kind of public statements about this kind of reflect this shift. And I mean, this is a field that used to have like a really high like sort of giggle factor. I mean,
Mhm.
people who are astrobiologists, that's the official term for folks who kind of study life on other worlds, and the prospect of that. It used to be really fringe, and it's not anymore. I mean, you have really like, yeah, kind of NASA higher ups like openly talking about finding life in the next 10 or 15 years, be it on Mars or some of these ocean moons. It's really moved into the mainstream. It's a serious pursuit. I mean, NASA has explicitly said that it's a big priority for them to actively search for life in our solar system. And yeah, so it's moved from the fringe into the mainstream, and that's a big deal. It means that we're trying really hard, and it's just not kind of confined to a few kooks. It's got a lot of really good hardworking people working on it, and it's getting some actual money involved too. So yeah, things are happening.
All right, cool. Well, that's definitely something to look forward to the next couple of decades.
Yeah, 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 definitely.
Yeah. Okay, then, in closing, then, the book is Out There, A Scientific Guide to Alien Life, Antimatter, and Human Space Travel for the Cosmically Curious. The author's our guest, Dr. Michael Wall, and you can find this book on Amazon. So, Mike, thank you very much for being an author story. I must say it was very interesting and very exciting speaking with you.
Thank you. Yeah, yeah. Like I really enjoyed the conversation. Thanks for having me.
You're welcome. So, everyone, particularly people who are just curious about the universe, by all means, check out there. And also, go ahead and check out some other books and authors whom we've already covered here on Author Story. And subscribe to our channel if you want. So, see you guys all next time on Author Story, where we will speak to another great author about another awesome book.